All right, so continuing on with the trig functions, our first stop is the inverse sine function. So what you see is the graph of y equals sine of x, and it is not one-to-one, meaning it's not going to have an inverse function. We saw that happen with y equals x squared. So what we have to do, we have to restrict the domain of this function so that we obtain all the possible values of sine x, which remember, the possible values of sine x are from -1 to 1. So we want to be able to take one piece of the curve so that the lowest point is -1, the highest point is 1, and I have nothing in between. And it turns out we can accomplish that by starting at this point here and ending at this point here. Getting more specific with these points, the lowest point is at -pi/2, -1. The highest point is at pi/2, 1. And you notice that it's 1-to-1. It passes that horizontal line test. And we only hit each y value once, and we do hit every y value once. So this is the main restriction for the inverse sine of x. Our angle must be between -pi/2 and pi/2. So what we're talking about is quadrant 4 and quadrant 1. And that's important to notice when we start to summarize these functions a little bit later. So okay, there's the piece of the graph of sine that we're going to look at. So when we go to find its inverse, and keep in mind, so the inverse, we have a special name. Your book calls it sine with a -1, and you've used this before. You use the inverse sine when you want to find the angle that corresponds to a given ratio. You plug in the ratio, you get an angle. So there's two notations for that. You can either use, like I said here, the sine with a -1, or you can use arc sine. I prefer that one because -1 exponents tend to confuse people, okay? But each of them means, so if y is equal to the inverse sine of x, that means x is equal to the sine of y. So interchanging those roles of input and output. So this means that the domain of this function is -1 to 1 because the range of the other function was -1 to 1. So when you interchange input and output, you interchange domain and range, something you probably remember from pre-calculus. And your range becomes your domain from before, and that's -pi/2 to pi/2. So if we flip all of that around, we get this graph right here. So there's the graph of the inverse sine of x. Okay, so I'm going to label it like so. So let's just get acquainted with a couple values here. If we want to find the inverse sine of 1, well, what is that? Well, we want to find the angle that when we take the sine of it is 1, and by looking at our graphs and whatnot, we know that that's pi/2. So we say that the inverse sine of 1 is pi/2. What angle gives you the ratio equal to 1? Okay? The inverse sine of -√2/2, well, I know this isn't first quadrant, so I'm going to start calling this the off quadrant. Meaning that it's not the first quadrant solution. Inverse sine, as we saw, it's only going to ever return an angle between -pi/2 and pi/2. If you remember your ratios, √2/2 corresponded to 45 degrees. So that means this is -pi/4. And that's because sine of -pi/4 is -√2/2. Okay? If that's a little confusing, I want you to think about this. Back when we first talked about square roots, maybe not we, but you did, if you were asked for the square root of 36, what did you say? Well, you said 6, and the reason is because 6 squared is 36. You had to go back to the more familiar function to understand the new function. That's kind of what's happening here. And last but not least, now we'll get to the properties down below here in a second. Use your calculator to find sine inverse of 1.2. So if you want to pause the video real quick and do that, you're going to notice a result. And I'm assuming you're back now, so you should have gotten an undefined answer. And what that means is there is no angle that's going to give you 1.2 when you take the sine of it. And that's because the domain of the sine function is -1 to 1, meaning I can't plug in anything outside of that or disaster happens. In other words, undefined. Almost as bad as dividing by 0. All right, so before we get into the inverse cosine, let's just talk about inverse properties. Remember that when you plugged an inverse into its inverse, or function into its inverse, the output was x. So Here we have rules though. So thinking about the order in which these functions are applied, if I take the sine of the inverse sine of x, I can only do this if I plug in a number between -1 and 1, okay? And out here, if I take the sine inverse of sine of x, well, that's only going to be equal to x if my angle is where it belongs, which is -π/2 to π/2. What happens when we do another angle? Well, we'll see. So let's just take an example, a couple examples here. So sine of inverse sine of 0.25. I'm okay with you using your calculator for that. That is going to be 0.25. It's within the range either way we go, so we're fine. Okay? Sine of inverse sine of -1.2 I know is undefined, and that's because this guy is undefined. So it's kind of like me saying, take the square root of -6 and square it. We don't want to go into imaginary numbers here, but this is undefined because I get stopped in my track when I try to find the square root of -6. Okay, now looking at this next one here. So π/6, we're taking the sine of π/6 and we're finding the inverse sine of that. π/6 is in either quadrant 1 or quadrant 4. So that means the angle is π/6. Now here's the interesting thing. If we take the sine inverse of sine of 2π/3, let's just take this in steps. This ratio, let's see, sine of 2π/3 is like saying the sine of 60. That should be √3/2. And that actually corresponds to π/3. And the reason for that is because this is not on the interval -π/2 to π/2. Okay, so it's going to take a little bit of getting used to, but just remember, it's all about remembering what are you allowed to plug into an inverse function and what are you allowed to get out of an inverse function. So there's your inverse sine function in a nutshell. Come back and we'll talk about the inverse cosine.